Good morning. I'm Steve Thompson. I'm here to talk today about SciKit-Surgery compact libraries for surgical navigation. This is work-based at the Wellcome EPSRC Centre for Interventional and Surgical Science as part of UCL. Today's talk, we're going to talk about three things. Motivation. What are the aims of SciKit-Surgery? Why have we done this? We'll describe how SciKit-Surgery meets these aims. With an example based on smart liver augmented reality application for liver surgery. A couple more examples. We'll talk about ongoing work and the main thing, how to use SciKit-Surgery and how to contribute to it. So we started off with three aims. We've been doing research in augmented reality surgery for several years and sort of noticed three areas that are lacking. So obviously for augmented reality in surgery, we need to provide tools to help researchers go from research algorithms to clinical applications quickly. Then we need to support these researchers in the dissemination of their algorithms in sustainable implementation so they can get them into libraries and get them out there so other researchers can use them. And lastly, we want well-engineered software so that we don't have to re-engineer things when we want to go from research to translation. So the first aim, what do we mean when we say provide tools for augmented reality research? If we look at what's required to get an application into theatre, there are six problem domains: imaging, medical imaging, segmentation, which is what we call medical image computing, registration of the images to the real world, tracking, visualization, and user interfaces. No single researcher can write code to cover all of these bases. So typically what you will do is you'll adopt a platform, and there are many out there. I've written two major ones, Slicer and MITK, plus our own one which we developed internally, NiftyK. And these platforms provide tools in these six domain areas so that you can then work on your little bit of science and build it into an application. Example of smart liver built with NiftyK. So we have developed over several years smart liver augmented reality application for liver surgery. It's got about 3,500 lines of code, but it's built on the NiftyK platform, which does all the visualization and user interface, a lot of the mathematics. And that's got 230,000 lines of code. It's all written in C++. It works well, but we were finding it was increasingly hard to continue development on that for various reasons, which we'll go into shortly. So we re-implemented Smart Liver, basically the same application, but we built it on SciKit-Surgery libraries. And here, SciKit-Surgery is not a single platform. It's a bunch of libraries that are independent and a lot smaller. So we've built it on 5 libraries, VTK, which does the visualization of surface models. It's about 4,000 lines of code, and Surgery Image, 3,500 lines, and it does all the sort of image manipulation, image grabbing. So we've got augmented reality. Then we have ways of talking to hardware, Surgery BK for BK medical ultrasound and NDI trackers. It's all built on Surgery Core. And the reason we've done this is because whilst NiftyK gives the appearance of simplicity, the platform itself, NiftyK, is so large and has such internal complexity that we find that we can't get researchers to contribute to it. And this leads to two things. One, researchers start implementing their algorithms within the application. So Smart Liver suddenly goes from 3,500 lines of code up to 10,000 lines. It's got all this code that can no longer be shared or reused by other researchers. The alternative is you get a team of software engineers to implement algorithms in the platform, but this obviously relies on having massive resources in terms of software engineers, which most research groups just do not have. It's something you might have as a private company, but not as academic researchers. And that this last thing is all about the second aim. enabling researchers to disseminate their algorithms. With SciKit-Surgery, the component libraries are small and they're well documented. Instead of using C++, we're using Python. And this encourages researchers to implement reusable code within libraries that can be easily shared and combined with existing SciKit libraries using Python. The last aim, well-engineered libraries that can be used in production. So typically, a lot of research academically is done on the assumption that you're building prototype code. You can prototype, you can do a bit of research, you can write your paper. If it all works, you can at some stage refactor the whole thing, getting some engineers in to turn it into production code. But the net result of that is massive gaps between doing your proof of concept result and getting clinical deployment. So SciKit-Surgery aims to avoid this. What we're doing, the way we do this is just by writing smallish component libraries to high standards, implementing software engineering process from the start. So we have continuous integration testing, documentation, everything is, all our changes are recorded, issue tracking, etc. So first example, I mean, this is the smart liver. It's been published elsewhere. It's ongoing research, but it's basically going in use in theatre, and it's all developed under ISO 13485. So the idea is it can be used as a medical device at some point. More lightweight applications, we've put these in the paper to draw attention to how quickly you can build an application using SciKit-Surgery libraries. So this is an example from our paper, Snappy Sonic. It's a public engagement demo, and the great thing about it is we designed and deployed the whole thing in 2 weeks. But we're also able to maintain quality control, so we're able to do the science and publish a paper on it as well. Second example, basic augmented reality demonstration. So this is software that was designed for use in teaching, but it's, because of the way it's engineered, it's highly extensible. We've implemented all sorts of user interfaces in it, like speech, push buttons, pedals, touch screens, and we're using it. Once we get back in the lab, we're going to use it for prototyping and testing clinical user interface, but it can be used anywhere. So during our lockdown at the moment, we were able to do some home science on the kitchen table. There's a nice video on YouTube you can check out. So that's SciKit-Surgery, open source, cross-platform. You can install it all from PyPy. It's easily findable on GitHub now. You just search SciKit-Surgery on GitHub or just Google it. There's a couple of tutorials out there. There's these links to them. You can, again, Google them. Here's a little screenshot of the wiki. You can go to that, raise issues, ask questions. So thank you very much for listening. A few more command line things you can try and links to the paper. From all of us, thank you very much. Cheers.